Okay, if any of you have any comments to make, I have a microphone here, so you can definitely bring the public in. I would ask you to maybe keep your comments until after we're done. And I'll put this on here so those people out there in the world, how many are there? There's no one at the moment. I haven't been very good at making it open to the Zoom public. I'll get better though. All right, so let me go to the next one here. So what is a plasma? Let's find out, because there's so much of it in the universe.
Out in space, particles play by a different set of rules than we are familiar with at home. The expanse beyond Earth is almost entirely filled with a mysterious state of matter. This matter is the least understood. It's rarely encountered on Earth, yet it triggers auroras and even impacts our exploration of space. This is plasma. After solid, liquid, and gas, plasma is the fourth state of matter. It is made of particles that have been ionized. This means the particles have been given so much energy that electrons separate from their atoms, making a subatomic soup. Unlike gas, plasma easily conducts electricity. This allows it to move along invisible pathways charted by the electromagnetic fields that fill space. While plasma is rare on Earth, it makes...
So I'm stopping just for a second. I'm going to back up just a little bit. So one of the things you'll notice immediately, back up a bit more, is that plasma can create organized structure. That's kind of the message I just want to give here.
Electromagnetic fields that fill space. While plasma is rare on Earth, it makes up 99.9% of the visible universe, including the Sun and other stars. It's also spread out across the universe and the space separating planets and stars. This space is not empty. It's filled with a weak soup of plasma. Those vast expanses of space are also filled with electromagnetic fields, such as those created by the Sun and Earth. In these places where plasma...
And I'll also stop it again. That structure they know of because they send satellites up. So this is not a fictional representation. This has been done by satellite research.
Also spread out across the universe and the space separating planets and stars. This space is not empty. It's filled with a weak soup of plasma. Those vast expanses of space are also filled with electromagnetic fields, such as those created by the Sun and Earth. In these places where plasma and electromagnetic fields play, plasma can undergo a unique explosive phenomenon called magnetic reconnection. Magnetic reconnection occurs where magnetic field lines are constantly shifting. When the lines become tangled, they explosively snap and realign. This transfers energy and sends nearby plasma particles flying through space. Magnetic reconnection triggers solar flares on the surface of the Sun, creates shock waves near supernovae, and violently twists plasma around black holes. Closer to home, magnetic reconnection between the Sun and Earth's magnetic fields is a critical way energy is transferred around our planet. For example, when magnetic reconnection occurs on the night side of Earth, it can push particles down toward the poles, triggering auroras. Near-Earth space is the easiest place to study magnetic reconnection, and NASA does this with its Magnetospheric Multi-Scale Mission, or MMS. MMS uses 4 identical spacecraft to measure magnetic fields and particles in 3D 100 times faster than previous missions. This has revealed new insights on the small...
So freeze it again. That's the image they built with satellites. So this is hard data. This is not something fictional.
Scale details of magnetic reconnection and the nature of plasma itself. Other NASA missions like Parker's Solar Probe, Themis Artemis, and Voyager also study plasma across our solar system. From the surface of the Sun to the space between the planets, NASA continues to unravel the mysteries of plasma that help us as we venture beyond Earth.
Bless NASA for producing such a wonderful Okay, so this is what I'm going to show you now is the classical explanation of a black hole seen through the eyes of a gravitational mathematics.
What is a black hole? Well, the name is actually a little misleading because black holes aren't actually holes. They're regions in space that have a gravitational pull that is so strong that nothing can escape, not even light. Scientists know about two different sizes of black holes, stellar mass black holes and supermassive black holes. A stellar mass black hole is born when a massive star dies. That's a star that's larger than our own sun. These stars burn up all the nuclear fuel in their cores, and this causes them to collapse under their own gravity. This collapse causes an explosion that we call a supernova. The entire mass of the star is collapsing down into a tiny point, and the area of the black hole is just a few kilometers across. Supermassive black holes can have a mass of millions to tens of billions of stars. Scientists believe that every galaxy in the universe contains a supermassive black hole. That's up to 1 trillion galaxies in the universe. But we don't know how these
I'm freezing this for a second. What do we know about black holes from observational evidence? Well, apart from M87, which I'll address later, everything you see here is an artist's rendition. The real data from the observational end of the spectrum and going into the infrared and the X-ray is about 10 pixels. So we don't have a clear idea of what a black hole is. Everything that we see is an interpretation based on gravitational logic.
Massive black holes form. And this is an area of active research. What we do know is that supermassive black holes are playing a really important part in the formation and evolution of galaxies and into our understanding of our place in the universe.
Okay, let's get a little bit more black hole stuff, just to hammer it home.
Black holes are among the most fascinating objects in our universe, and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return beyond which we truly cannot see. When something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers.
Okay, I just want to freeze that there for a second. The blasting of the jets is not at all predicted by black holes. There's now explanations for it, but there's no laboratory function that has been exhibited by this method.
Studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
Okay, let's move on. This is Anthony Pratt, and we met in 2013, had dinner. We had done a lot of correspondence since then. Anthony Pratt is like the former, he is now, I think he's got Alzheimer's at this point, pretty far along. But he's the foremost plasma physicist in the United States, or was at the time. He was there for most of the nuclear bombs that took place, and had some influence in what they would do to measure the trigger of the nuclear weapons. I asked him, did you guys ever put a gravimeter next to one of these? The gravimeter basically measures gravity. And according to present theory, it shouldn't have any effect whatsoever on the gravimeter. But it was not, he said, no, they didn't have time for that. All they wanted to do was do a big firework. Let me go back to here. So I'll bring him up possibly bring him up from time to time. One of the things we talked about was how plasma structure occurs. And we both basically believe, and I rest on him as a sort of, hey, you believe that too, that the electrons and protons in an organized plasma, the electrons are in one spiral and the protons are in another spiral. And one day when we managed to get the camera slow enough to look at a lightning bolt, that's what we both expect to see, but we just can't get the cameras slow enough, fast enough to be able to capture the moment. So let me go back to here. Okay, so there's a school of thought out there. These are the heretics of science. They publish in the IEEE, which is the electromagnetic journals, won't be let into the cosmological journals. That's like still like verboten. So they have to publish their information in these. So I'm going to show you this short video first. Oh, sorry. There.
At the heart of the dense plasma focus are two cylindrical electrodes only a few inches across, nested inside each other. The electrodes are enclosed in a vacuum chamber with a low-pressure gas filling the space between them. A pulse of electricity from a capacitor bank, an energy storage device, is discharged across the electrodes. For a few millionths of a second, an intense current flows from the outer to the inner electrode through the gas. Instabilities first compress the gas into dense filaments. These filaments are little whirlwinds of plasma. The sheath of filaments converges together into a dense pinch or focus, combining all the filaments into one. This filament kinks and twists itself into a tiny dense ball only a few thousandths of an inch across, called a plasmoid. Instability in a plasmoid creates powerful beams in opposite directions. Positively charged nuclei flow in one direction, and electrons flow in the other.
There's your jets.
The electron beam heats the plasmoid to billions of degrees, hot enough to fuse nuclei together to release fusion energy. In sum, the DPF operates by leveraging electricity to induce a plasma state for some gas. It then exploits a series of instabilities within the plasma to bring about controlled nuclear fusion. We call this focus fusion.
And to date, again, I'm linking observational evidence, what we've done and what we expect, what we interpret, to date, and I'm going back now 50 years since the first tokamak reactors were built and inaugurated. They have not, still haven't, successfully controlled nuclear fusion. So what is nuclear fusion? Well, basically, to get nuclear fusion, you want to fuse electrons and protons together. And by smacking them together, that produces an energy output. What we're using right now is in nuclear reactor is nuclear fission, where we smash things apart, which we're very good at as human beings. But fusion is supposed to be a lot less radiation and a lot more efficient. Only problem is that every time we build, and they have now built quite a few versions, there's laser reactors and everything, they're lucky if they get 10 seconds of power out of, and they pump a lot more power in than they get out when they do these things. So it's a little bit like blind people building a cage for an animal they've never seen. We simply don't have, every time they fire these things up, the plasma inside creates its own idea of what it wants to do. It basically goes to the scientists and just jumps out of the containment field. So we don't understand it at the moment. If I had my druthers, if I was president of the United States, I would shut all those down, which are spending, now it's been trillions of dollars, and I would spend all my money on garage and basement mad scientists to just go to town and do whatever weird thing they would do and see if any one of those groups would come up with something, because they'd be a lot cheaper, and I think it would be a lot more possible, because there are secrets that we have not managed to unfold yet. We have these interpretations, and we know they're wrong. There was a guy here who was one of the members some 5 years ago, who said, yeah, I started as a nuclear scientist, and I just looked at it after 3 years and said, you know what, I'm going to do something else with my life. Because he knew that what they were building was just a waste of time, just money going into the pockets. Most of them know that it's not going to produce anything. Only the religious will do. But this one here is interesting because it's in a lab. That makes it much more interesting. Let's see what else I have with this one here. Yeah, carefully press it. This is a heretic. This is Eric Lerner. He wrote a book in the early 90s called The Big Bang, something like The Big Bang Doesn't Exist. And he laid out his tenets why this would be so, and his interpretations of the cosmic redshift and of the background radiation. And he was laughed at, basically pushed to the side. When the Webb telescope opened up in 2022, all the media, they'd seen his book because they were seeing galaxies right up against the event horizon. Now notice I didn't say the Big Bang. I can refer you to last week's presentation on the Big Bang, but I'm not going to do that today. This is the horse we're riding right now. But basically, he was right, they were wrong. And since then, if you go into Wikipedia, they'll still say it hasn't been changed. They say, well, they all are against him because, his interpretation of background radiation was wrong. No, that's not true. Latest paper that came out, and I won't go into details, basically confirms what background radiation is, and it ain't the last gasp of an exploding Big Bang. The other thing he was talking about, the galaxies will be found right up against where they think the Big Bang is. He was correct. And again, they are struggling so hard to try and push a square peg into a round hole. And again, something I don't want to touch base with, because we're dealing with black holes right now. So let's do that.
So why don't the astrophysicists and cosmologists think about the possibility, or talk about the possibility, that these objects are plasmoids and not almost black holes, or what they prefer to call black holes? Don't they know that objects in space have strong electrical and magnetic fields? Well, they do. But the problem is they're not figuring it right. They're using an approximation that is easy to calculate, that is called magnetic hydrodynamics, or MHD for short. This is an approximate way of calculating electrical and magnetic fields that was invented by Hannes Alfvén, who won the Nobel Prize in Physics in 1970, back over 50 years ago, for dense plasmas like the plasma in our own sun. The problem is they're using them for plasmas that MHD is
Just a footnote here. Hannes Alfvén got the Nobel Prize for plasma physics, and his publications in cosmological journals was completely swept aside. He found it most frustrating. Most cosmologists weren't even aware of what a plasma was, still aren't. He is the student of Anthony Pratt, who I showed. He and Anthony Pratt follow similar lines of study.
Completely invalid for. And Alfvén, in his Nobel lecture, criticized astrophysicists 50 years ago for using MHD where it is not an appropriate approximation. And he said they're creating pseudoplasmas with pseudo-theories. And he joked, unfortunately, the plasma doesn't know about these theories and absolutely does not obey them. The reason MHD doesn't apply is because in a plasma that isn't very dense, and this object like M87 is not very dense, it's less dense than the air I'm breathing right now, powerful magnetic fields force charged particles like electrons or protons to move around magnetic field lines. So they're trapped on the magnetic field lines. And collisions are relatively unimportant. So that means that the ability of currents to travel along the field lines is very high. So there's very good conductivity along field lines and very poor conductivity across field lines. It's very hard to move across the magnetic field. In MHD approximation, it's exactly as equal to move across or along. So this is so different, you get completely wrong answers. And one of the indications you get a completely wrong answer is astrophysicists have been scratching their heads for decades to try to explain one of the most prominent phenomena that these condensed objects produce. At all scales, from stars up to these huge objects, these condensed objects produce jets of energy, electromagnetic energy, that come out in tightly collimated beams.
These are the jets we're seeing.
And MHD doesn't explain that. And the reason is it's the wrong theory. But we've actually observed such beams in experiments in the laboratory for the last 50 years. The cosmologists have ignored these experiments because they feel their theories that are developed for the great cosmos don't have anything to do with experimental results. And you can see, even today, 50 years after Alfvén criticized this, papers being published that don't refer to laboratory results.
Okay, so I just showed you more extent. He was the guy whose book got published, so that's why I thought we would show him. And we're now going to move on to the big pooba that about 5 years ago, M57 was looked at, and they said, "Oh, look, we've put several telescopes together, we've coordinated them, and this is the image we've come up with. This is a black hole." Now, the funny thing is that it looks more like a donut, which is more like what Anthony Peratt is showing on in his experiments than this thing here. I'll be touching a little bit more on that. Gosh, time flies fast, doesn't it? Let me see if I go to the next one here. Okay, so I'm going to play this one here. We saw that already. There's no sound, we've got no voice. So remember we saw the accretion disks in the, you had the big black hole in the center, and around it all this stuff is swirling. What is that stuff that's swirling around there? It's a plasma. That's not observation. That has been predicated on gravitational mathematics, totally ignoring plasma physics. So they treat the white area here as just a turbulent gas. I've seen that so many times written in paper. Every single image you see here is an artist's rendition of a black hole, except maybe that one right there. This is one of the reasons why it has its own momentum. Black holes are much beloved by the public. And what I did was I used Google Scholar, and this was 5 years ago, and I just checked yesterday. Google Scholar, and I typed black holes, and in all the papers, and there's many more. There's like 23,000 articles about black holes with the word plasma in it. But there are 3 times as many that don't even use the word plasma. Think about that for a second. All this plasma floating around, and they can't be bothered to look into what the behavior of plasma is. So everything, those multiple black hole papers that are produced are exclusively quantum mechanic and gravitational. Okay, there's the black hole, supposedly, which is really a donut. And I'm not the only one who's looking at this and saying, there's an outcry. If you took all the people who are interested in this, about half of my finger here are a group of physicists and electrical engineers who basically say, they're just plastering this out as complete rubbish, calling it, a black hole without actually describing what this thing is. So let me go back to here. universe superimposes right on top of the other space. And so the question is asked, well, where's the accretion crystal that's supposed to be there that gets absorbed into the black hole? As you can see, this is the classical black hole. This area here, by the time it gets to here, this is just electrons and protons, not any solid left. And the thing about this rotating thing, this is called a dynamo effect. And all of the electrons, all the protons start to react as a unit, as a unified object, as a unified configuration. And so and again, the best we have is that donutty image. That doesn't exist in the donutty image. It's not there. And these jets that they do here, there's no observation in the classical model, but there is in the laboratory experiment where one is electrons being shot off in one direction and protons being shot off in another direction. Bizarre, weird, and interesting. And why they do that, who the hell knows why, although there are papers about the electrical experimentation version of it. It's not there, it doesn't exist. So we're seeing it head on. This part is yours truly. 40 years of study. I believe that those plasmoids, because that's a plasmoid, I believe that they induce gravity. That you can't induce gravity with a liquid, you can't induce it with a gas, you can't induce it with a solid, but I think you can with a plasma. And there's an experiment you can perform that would verify that, which hasn't been performed yet. No one's ever tried it. So I'm suggesting that black holes actually produce of a lot less mass than we think they are. And the other thing is, the human idea, going back to the Middle Ages and the Dark Ages, was that things that erode and fall apart is like going down a chain into corruption. And here we are again with our cosmologists, this chain going down into, all the matter is just going down in a hole. We don't know where it goes. It's like as if the universe is determined to have these dumpsters that they're throwing all the matter in for whatever. Why would the universe do that? So from a purely philosophical level, I think that's just so daft. But I'm not going to go into the gravitational thing a whole lot today. Just going to touch on this. So let me see what the last. Let me go back to here. Okay, let's watch someone else do something interesting.
Hey folks, this is your plasma cosmology made easy. The goal is to deliver key points to help frame the plasma picture, from stars and star-forming regions to the galaxy and galaxies beyond, out to the large-scale structure of the clusters of galaxies and interconnectedness of the cosmic web. At the end of this video, you will get a number of links for supporting information and much more. The video is the highlights. The plasma cosmology is meant to one day replace the current lambda cold dark matter paradigm. In this paradigm, dark matter dominates the physical mass of the universe that began with the Big Bang 13.7 to 13.8 billion years ago. It's simply wrong on both counts. Let's begin with the timeline. We see supermassive quasars at such early times of the universe that it genuinely challenges the physics of how they could have formed so quickly. The same goes for supermassive galaxies. They are appearing at such a size at such early times that reconciling the Big Bang timeline is troublesome. A few weeks after the film was released, Gemini and others found a galactic protocluster at 12 billion years of age. Can tell it's been coming together.
And I just want to point out, this was actually done before the James Webb Telescope. And I wanted to show this not just me or Eric Lerner who's looking at this, but there is a group of very serious scientists who are trying to tackle this from a completely different perspective, and they base theirs instead of on theory, on observational evidence, in my opinion.
For a while, and its size once again becomes challenging at that age of the universe. But perhaps the most damning evidence comes from individual stars. They say that the earliest that stars could have formed was 200 million years after the Big Bang, but there are at least 2 stars we know of, not just in our own galaxy, but within 1,000 light years, that are as old as the Big Bang or older. Methuselah's star is thought to be 14.5 billion years old, maybe older, and is only 200 light years away. The galaxy is 100,000 light years across, so what are the chances it's the only one that exists? The only one that exists in our galaxy. Another interesting point is that most deep space background interpretations utilize Kirchhoff's law. One of the world's experts in radiology, someone who revolutionized the MRI machine, by the way, says it is wholly invalid, and he proves it in the cosmology film. Perhaps the most obvious failure is that billions and billions of dollars for satellites, telescopes, detectors underground, lab experiments, etc. have all failed to find even one piece of dark matter. And it's not only that, but the expected places to find their effects indirectly, like the gamma ray background and in dwarf satellite galaxy configurations, just isn't there.
Now, I'll stop here because this is just in the digest. But what these guys are saying is space is not empty. You take a cubic meter of space but in an intergalactic space, the thinnest space we know of, and in that space there's about 5 electrons, 5 protons, they estimate. This is a guess, right? There's neutrinos passing through it. There's radiation, background, what they call background radiation passing through it. So space is a fabric. And what these guys are saying is, yeah, and basically all these electrons and protons are creating a fabric that we don't understand yet. And that is what they think is dark matter, because it's making the behavior of certain objects. Where they try this, they don't look at electromagnetic. They say, well, it must be something gravitational. Let's call it dark matter. And he's quite right. Even to this day, this was 5 years ago when this was filmed, even to this day, they've not ever found a laboratory test or any kind of strict observational evidence that shows either dark matter or dark
In
energy.
fact, the satellites of the Milky Way, Andromeda, and Centaurus A all violate that mainstream dark matter model. But this is only half the story. It's not enough to just identify a problem. You have to at least point in the right direction. Galactic rotation is one of the key reasons they look for dark matter. They can't account for how the outer stars and galaxies keep up with the spin when they should just be falling behind and stringing out. There isn't enough visible mass to account for their continued curved keeping pace with the rest of the galaxy. And so they blame dark matter, magic particles that don't really interact much with the normal matter we know. But, alas, there have been a number of solutions proposed, and the best one is relatively simple. You replace their huge dark matter halo around the galaxy with a real normal luminous matter halo that is simply too hard to detect at this stage of our technology because it is so cold, sparse, and diffuse, spread out. Now obviously, this would work mathematically, but the problem is we don't see the stuff there. Until now. The lost light of Hubble was a late 2018 discovery that we heard about in January 2019. Color is the known galaxies, with black around them as the real matter halos that we already knew about. White is still black, blank space, but the gray is the recovered light, the lost light of Hubble. In the same space that was supposed to be occupied by dark matter to make the math work, it is instead populated by diffuse, cold, normal matter. And just when we thought that can't get any better, it was discovered that those cold, normal matter halos are co-rotating with the galaxies, aiding in the spin dynamics problem. And then Keck, Caltech, and NASA teamed up to discover that those galaxies are are fed from the cosmic web in spiraling helical vortex filaments. Can't get more magnetodynamic than that. We also have seen the math work when some of the stars within the galaxy are hyperbolic, and if indeed mainstream science is right about the galactic mergers over time, why would there not be wild, high-velocity stars on hyperbolic orbits? By the way, there are. They have found many such high-velocity stars.
And this one here is by yours truly. I did this about 5-6 years ago.
Hello, my name's Stephen Goodfellow, and today I'd like to talk to you about why black holes don't exist. By now, pretty much everybody is familiar with the black hole concept. A central body accumulates so much mass that its gravity becomes so very powerful that light itself cannot escape its grasp. But black holes cannot come into existence because of the plasma barrier. Consider, if you will, a gravitationally powerful central body of mass, which is at the point where surrounding accretion disk matter is pulled in with such force that it's spinning so fast that it causes the substance of the disk to become a hot soup of disassociated electrons and protons. In this state, the accretion disk no longer is a solid, liquid, or gas. It's become the fourth state of matter, which is referred to as a plasma. Furthermore, the rapid rotation imbues the plasma with a dynamo effect, allowing the plasma to behave as a single entity in which the electrons and protons all behave in unison. In this state, the plasma has an electromagnetic potential of 1 × 10 to the 39 times stronger than the gravitational force, so that if even a small fragment of this force is present, this electromagnetic force of the plasma accretion disk would easily overwhelm the initial imposition that the central gravitational mass initially had. The central mass now becomes an exceedingly minor player and may even be ripped apart and consumed by the plasma configuration. What happens then? No one knows, but it certainly isn't a black hole, at least not in the way that is presently envisioned. So, superhot plasmas in a dynamo configuration act as an impossible barrier to black hole evolution. The fact of organized plasma configurations overwhelms and extinguishes any realistic possibility of the present black hole explanation. Black holes are an artifact of the mind, exclusively derived from a gravitational model that completely ignores plasma behavior. The current explanation of a black hole is either a willful denial of plasma behavior, or it's just the result of plain good old-fashioned, unforgivable ignorance. They are fantasy and have nothing whatsoever to do with observational evidence. So forget those artist renditions of black holes that continuously bombard you in the media. They are compelling, beautiful, but a complete fantasy. Now, I can almost hear you say, "What's all this nonsense about organized plasmas? Sounds to me like a load of hogwash." So, not wanting to leave you disappointed, here's a real observation of an organized plasma telling gravity to go take a hike. Take a look at these plasma loops on the sun. As plasmas go in the universe, solar loops are a very weak example. Yet, observe these superhot slinkies effortlessly suspending billions of tons of matter in these gigantic magnetic loops. The sun's gravitational field is a crushing 28 times that of our planet. Now, take a look at those loops. Do they look like they're being particularly bothered by the sun's powerful gravitational attraction? No, they're not. Thank you for watching. Goodbye.
Okay, guys, that's my, thank you very much. That's my presentation for the day. And I'm open to questions. Anything I can answer, I'll try to.